Hi, welcome to our presentation on partition testing. So partition testing is equivalence class testing and boundary value analysis. Essentially it boils down to this idea that when you have a lot of data that you can't test every single data point in, you're going to divide it into data groups that are alike so you can make tests off of that. So equivalence class testing is essentially that idea of dividing these groups of input data into equivalent partitions that can be used to derive test cases, which reduces the time required for testing because of small number of test cases. So it kind of looks like this, it's kind of a confusing thing to show, but basically you're going to divide it up into groups like mobile, laptops, pen drives, keyboard, headphones, and then you're going to see on the right here you have valid, invalid, invalid. So there's going to be multiple invalid partitions and one valid partition. So right here we have this thing about pizza. It doesn't matter what it's about, but 1 to 10 is valid. Anything above or below that is invalid. So the testing is going to be basically determining, did they order 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, or did they order something above or below that? So that's an example of equivalence class testing. That's what it looks like, and that's also an example of that's an example of the partitions and equivalent classes. So basically, the advantages of this is that you can reduce the number of test cases without compromising coverage. It reduces overall test time execution. Can be used at any point, any level of testing, unit, integration, system. Enables testers to focus on smaller data sets, which increases probability of uncovering defects. And it is used in cases where performing exhaustive testing is difficult, but at the same time maintaining coverage is required. So it does not consider the conditions for boundary value. The identification of equivalence classes relies heavily on expertise of testers. Testers might assume that the output for all input data sets are correct, which can become a great hurdle for testing. So basically, that's a lot of the problems and it also, as things change, the tests might become outdated or the data sets might become outdated, and it focuses on specific equivalence classes, which means that some cases or uncommon scenarios may be overlooked. So boundary value analysis is checking the extreme ends of these value sets, these partitions. So in that pizza example, you'd be testing at 1 or 10, and that is good because it can help you check off those off by 1 errors, overflow errors, boundary condition errors, and you can test only a few values at each boundary instead of testing every possible value. It can improve the quality, reliability of your software and reveal defects in functionality, performance, and security. But it is not suitable for testing complex input domains that have multiple boundaries, interactions, dependencies. Also might miss some errors that are in the middle of the input domain or caused by other factors like logic, data, environment, and also may require some assumptions and estimations about the input domain which might not be accurate or consistent, and also depend on the quality and completeness of specifications and requirements which might not be clear or available. So this is the main thing. You take 8 lowest and you chop off 1, you take the highest, add 1. And that's how you establish your range, the boundary values to base your tests off of. So in our pizza example, it would be 0 and 11. So anything above that or above or below would be invalid. So, or you'd want to test that things don't cross over on those values as well. So what are the previous posing techniques? So equivalence classing testing can be done at any test process, usually done with black box testing. BVA is done specifically to push the boundaries of the system. However, BVA and equivalence partitioning are used together to find bugs and boundaries. Another helps to determine that exists between the defined range of the value inputs. Usually applied in the test design phase of the software testing lifecycle. We're creating and documenting test cases based on requirements and specifications. These techniques can be used during the test planning phase to define scope, strategy, and testing and objectives. So the roles and responsibilities are similar to any other test, but all you really need is a good test analyst who can read the requirements and the specifications well, and might coordinate with a software engineer to understand and fix the code base. But supplementary roles like test manager, quality assurance team, and test architects, people who can guide and check progress and determine if the quality of the test is up to snuff for the client's project, would also be helpful. So that is our presentation on partition testing. Essentially, it's this idea of dividing alike data into groups and also testing the edges and the data and creating these data groups to reduce the number of test cases so that you can test more efficiently in these examples where you're not going to be able to do that. So, and these two things go hand in hand to help each other be thoroughly test these data sets. So, yeah, thanks for watching. I hope you got something out of this.